Hello, Algebra students. We are in section 9-6, day 2, the last section for this chapter, and we are talking about how to solve word problems that are quadratic equations, and we're going to be applying the quadratic formula in these. So what I'd like for you to be able to do by the end of this lesson is to solve word problems using the quadratic formula and by substituting incorrect values for the appropriate variables in these word problems. So we are going to jump right in. In this first example, we are talking about a ball being tossed into the air. It says, after t seconds, a ball tossed in the air from the ground level reaches a height of h feet, given by the function h of t is equal to negative 16t squared plus 144t. So right off the bat, I just want you guys to know h is basically meaning height. T is meaning time in seconds. That's what we need to know there. And we can figure out anything we want based off of this equation. So it says, what is the height of the ball after 3 seconds? Well, 3 seconds is a time. That's a time value. So I'm literally going to take this 3 and substitute it in for the time to figure out what the height will be. So let's do that. I'm going to take negative 16 times 3 squared plus 144 times 3. So now I'm using my calculator to get this. This is 3 squared, which is 9, times negative 16, which is negative 144, plus 144 times 3 is 432. So now I'm just taking negative 144 plus 432, and that is getting me 288 feet. So what we've just answered is this ball got thrown from the air and it's going up into the air and then it'll come back down. But after 3 seconds in the air, it will be 288 feet up in the sky. Now next it says, what is the maximum height that the ball will reach? So what I want you to think about that is this. So we've got the ground right here. This is the ground. And it starts, let's say the ball is here, and then it gets thrown into the air. So it's getting thrown up, and then, of course, it's going to reach a certain point, and then it's going to start coming back down. And then it's going to bounce, right, and it'll go up and down again. But what we're concerned about is this point right here. What is the very highest coordinate that it's going to reach? Well, that is the vertex. This is the vertex of a parabola. So if we can calculate the vertex from this equation, then we know what the maximum height would be. So to calculate the vertex, you're first going to calculate the axis of symmetry and then substitute that back in. So first, axis of symmetry. So that's negative b over 2a. So looking at this, my b is the 144 and my a is negative 16. So that's going to be negative 144 all over 2 times negative 16. Well, that reduces to negative 144 all over negative 32. And that's getting me 4.5. Now remember, the axis of symmetry is not the vertex. Now I need to take this 4.5 to substitute it back in. So second vertex. So I'm going to take this 4.5 and I'm going to stick it back into my original problem. So that is negative 16 times 4.5 squared plus 144 times 4.5. Okay, when I stick all that into my calculator, let's see here. I am getting 324. So I just used my calculator to simplify this down, and I'm getting 324 feet. So what this is saying is after 4.5 seconds, the ball reaches 324 feet, and then it will start coming down again. So it's going up, 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 up for 4.5 seconds, and then it reaches its highest point, and then it starts coming back down. The next question is, after how many seconds will the ball hit the ground before rebound? So at this point, we're asking ourselves, when does the ball reach 0? When is the ball along the x-axis or the ground? Those are the roots. So here we are solving for roots. So we have lots of strategies to do that. Because this is a simple equation and we're able to factor it, I'm going to solve by factoring. So I'm going to set this equal to 0, and I'm going to say 0 is equal to negative 16t squared plus 144t. Now I'm setting this equal to 0 because I want to know, remember this is height is equal to all this stuff with time. I want to know when the height is 0. When does it touch the ground again? So that's why I'm setting the height equal to 0. So now I'm going to factor out from these two the GCF. So this is 0 is equal to negative 16t because I can pull a 16 and a t out of both of those. And that's leaving me with t minus 9. Now at this point, I'm using my product property of 0, and I'm going to set that set equal to 0 and this set equal to 0. So I've got negative 16t is equal to 0, and I've got t minus 9 is equal to 0. When I solve for t here, I'm getting t equals 0. But when I solve for t here, I get t equals 9. So here's what I want you to think about. In this one, it's saying after 0 seconds, the ball is at ground level. Yes, that's true. But that's because it is just now getting launched from the ground. This one is saying after 9 seconds, the ball is at ground level. So it's at ground level, and then it goes up, and then it comes back down. That makes more sense because now it has had time to come back down. So I'm going to go with this one, 9 seconds for that one. After how many seconds will the ball hit the ground? Let's do another very, very similar problem to that. Number 2 says, a rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by this function. So we've still got two things going on. How is the height changing in comparison to how much time is passing? So we've got h is equal to height, just so we're aware of it. T is equal to time. Okay, and it says, what is the height after 1.5 seconds? I'm literally going to take that 1.5 and stick it in for t, because I'm trying to figure out what the height would be there. So I'm going to say height is equal to negative 16 times 1.5 squared plus 64 times 1.5 plus 80. Now I'm just simplifying this out. So 1.5 squared times negative 16 is negative 36. And 64 times 1.5 is 96. And then we still got plus 80. So when we add all those up, 80 plus 96 plus 36, that is getting me 212. No, not 212. This is a negative 36. My apologies. So let me say that again. We've got negative 36 plus 96 plus 80, and that is getting me 140. There we go. So all I did was take that 1.5 second value, substitute it in for t, and then simplify. Next it says, what is the maximum height reached by the rocket? So remember, this is very similar to that one. The rocket, I don't know, I'll draw it like that, and then it's got some flames shooting out of it. It's going up, 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 up. It's going to reach a highest point, and then it's going to start coming down again. What is that highest point up here? The highest point is going to be the vertex. So we want to calculate that. And the way you calculate the vertex is by first calculating the axis of symmetry and then substituting that back into the equation. So axis of symmetry, first axis of symmetry is negative b over 2a. Well, in our equation up here, which is this one that we're using, this is the equation we're using, negative b would be negative 64 all over 2 times a, which is negative 16. Okay, simplify that. Negative 64 over negative 32. Well, that is equal to positive 2. So right now, we've got 2 seconds, and that's all we know. So how tall is this going to be after 2 seconds? I'm going to take that 2, I'm going to stick it back into the original problem. So second, we're officially finding the vertex now. So we're going to say height is equal to, and we're going to write this equation, but instead of t, I'm going to put my 2 value in. So height is equal to negative 16 times 2 squared plus 64 times 2 plus 80. Okay, we're just simplifying this out. So I have 4 times negative 16, and then I am adding 128 to it, and then I'm adding 80 to that, and I am getting 144 feet. So when I just simplified this down in my calculator, I'm getting height is equal to 144 feet. So for this rocket, it's getting launched up, and it's going up, 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 up. It reaches 144 feet, and then it's going to have to start coming back down. This next question says, after how many seconds after it is launched will the rocket hit the lake? So when will basically the height of the rocket be 0? When will it land in the water? When will it be in the lake? Okay, when it's at the lake, the height will be 0. Remember, this h of t means height, and then all of this tells us how to calculate the height. So we're going to take this equation and set it equal to 0. So I'm going to say 0 is equal to negative 16t squared plus 64t plus 80. All right, I don't really want to factor this one, and I want to show this to you guys with the quadratic formula. So let's say we're like, okay, let's not factor, let's use the quadratic formula instead. Well, we've talked about that in our previous lesson. That is negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can use this to figure out the solutions to this. So let's substitute those values in. I'm going to say negative 64 plus or minus the square root of negative 16 squared minus 4 times negative 16 times 80 all over 2 times negative 16. It's pretty complicated, but we're going to get it simplified down. Okay, so our next step is to just start simplifying. So I've got negative 64 plus or minus the square root of 16, or negative 16 squared is 256. And then when I take negative 4 times negative 16 times 80, that's going to be quite a bit. So negative 4 times negative 16 times 80, that gets me 5120 all over negative 32. So let's add these two things up, and that is going to get me 5,376. I'm just going to erase these two numbers and put them together because I'm kind of running out of space. Okay. Let's see if we can get a square root value for that. So what I've done so far, just so I can reiterate, I wrote my equation out, it's equal to 0. I substituted into my quadratic formula. Now I'm simplifying. So we've got All righty. So, oh, I know what I did. I was trying to think, I thought, what on earth? This is not making sense. This needs to be a 64. I apologize, you guys. I made a mistake. So this 64 squared should have been 4096. And then I knew I had a mistake. I apologize, you guys. So I've got 4096 plus, and then 4 times 16 times 80. 5120. Okay, these add up. I'll just write it over here, I guess. Negative 64 plus or minus the square root of 99216 over negative 32. But what is the square root of 9,216? It is 96. There we go. I knew I was having an error somewhere. Okay, so I've got negative 64. If this were to be broken down, I'll write it in a different color so you can see my final step. I've got negative 64 plus or minus 96 all over negative 32. Well, when I plug these into my calculator, if I take negative 64 plus 96, and then divide that by negative 32, I get negative 1. So what this means is the rocket is touching the ground at negative 1 seconds. Well, that doesn't make much sense. So let's try this again using subtraction. So now I'm taking negative 64 minus 96, and then dividing that by negative 32, and now I'm getting 5. So that answer makes more sense because I can now have a positive time value. So I am going to say 5 seconds for that answer. All right, we just have one more example on the back. So on the back it says, a rock is thrown from the top of a tall building. The distance in feet between the rock and the ground in t seconds after it is thrown is given by this function right here. How long will it take the rock to reach the ground? So basically, we've got a big tall building. And then we got, I guess, somebody up here just doing experiments, and they're going to throw a rock off, and we're wondering, when will the rock be at 0? When will the rock hit the ground? So if distance is 0 to the ground, I need to set this equation equal to 0. So I'm going to say 0 is equal to negative 16t squared minus 4t plus 382. Now, our options are to factor, to graph, or to use the quadratic formula. So those are my 3 options. We don't really want to graph. We might possibly be able to factor, but these numbers are kind of big, a little inconvenient, so we can try the quadratic formula. Also, just so we can practice it a little bit more. So I'm going to use the quadratic formula, but you might be able to do something else. I don't know. So that is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, we're going to take our values and substitute them in. So my b is negative 4, so I'm going to say the negative of negative 4 plus or minus the square root of, and then I'm going to say negative 4 squared minus 4 times negative 16 times 382, and my square root wasn't long enough, all over 2 times negative 16. The only thing I did was take my a value, which is negative 16, and stuck it in for the a. The b value, which was negative 4, and I stuck it in for the b's. And the c value, which was 382, and I stuck it in for the c. Now I'm going to start simplifying. So the negative of negative 4 is positive 4. And then this is 16 plus 4 times 16 times 382. 4 times 16 times 382 is 24,448. All over negative 32. So now I'm going to get 4 plus or minus the square root of 24,464. And when I put that into my calculator, I am getting not the most even number. It is a little bit of a funky number. It's about 156.4. So now this is becoming 4 plus or minus 156.4 over negative 32. So when we substitute that into our, so all we did, we took our A, B, and C, substituted in, simplify, simplify, simplify. Now it's time to add these up and figure that value out. So if I do this, if I take 4 plus 156.4 and then divide by negative 32, I'm getting t is equal to negative 5. What happens if I say minus? So I'm taking 4 minus 156.4, dividing it by 32. Here I'm getting positive 4.8 about. So this is saying at negative 5 seconds, but that doesn't make much sense. This one's saying at positive 4.8 seconds. So we're going to have to go with that because we're not going to have a negative time value. So after 4.8 seconds, so this person throws the rock and it's going down, 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 down. At 4.8 seconds, the rock will hit the ground, or at approximately that amount of time. All right, that's all I've got for this note video. I hope you have a wonderful night.